Discussion of the capabilities of rail transportation requires discussion of the application of rail transportation in Europe. Everybody knows Europe's passenger trains are all bullet trains. Well, they know there's some commuter trains too. There's no freight trains in Europe, or they all run at night. You hear both. Freight trains and passenger trains need separate rail networks, and high-speed trains need a network separate from the other passenger trains. Highway haul of 500 miles at either end of a rail haul is normal and necessary, or at least everybody but Europeans. Here is a sample of two double-track railroads, one in Germany and one in the U.S. The German line has 58 freight trains and 48 passenger trains eastbound, and 59 freight trains, 46 passenger trains westbound. There's not 1 hour of the day that does not have two freight trains. The U.S. line has 31 northbound freight and 5 northbound passenger trains, and 20 southbound freight and 5 southbound passenger trains. The German double-track line handles 211 trains per day. The U.S. line handles 61. There are numerous freight hauls of less than 500 miles in Europe. There's carload freight in Europe. The largest rail classification yard in the world is in North Platte, Nebraska. That's probably not a surprise. The second largest rail freight classification yard in the world is in Hamburg, Germany. Yes, Europe has that kind of freight trains too. Apparently Russia and China have not heard that passenger trains cannot coexist with freight trains. China and Russia have higher freight density than the U.S. Russia has over twice the passenger traffic density of the U.S. China has over 7 times the passenger traffic density of the U.S. These figures were obtained before China started developing its extensive network of high-speed rail. Europe has long-distance passenger trains. There's 1 train per day between Lisbon, Portugal, and Vladivostok, Russia, 6,274 miles. It consists of 6 connecting trains, but the trains actually connect, with a short wait at the connecting points. The total trip is 223 hours, an average trip speed of 28 miles per hour. Do people ride the entire trip? Probably not, but the trip is available for those who want it. There is no rail service between New Orleans and Jacksonville, Florida, 504 miles. Paris to Bologna is 522 miles. There are 6 trains each way per day, involving 2 to 5 connections, taking 10 to 15 hours, an average trip speed of 35 to 52 miles per hour. Do many people ride this entire trip? Again, probably not, but the trip is available for those who do, and of course for those at intermediate points all along the line. Chicago to Denver is 1,000 miles. There's 1 train per day, taking 18 hours and averaging 56 miles per hour. Paris to Stockholm is also 1,000 miles. There are 6 trains per day each way, requiring 3 to 9 connections, taking 22 to 32 hours and averaging 31 to 45 miles per hour. Chicago to New York City is 800 miles. There are 2 trains per day, 1 requiring 2 connections. The trip takes 19 to 21 hours, a speed of 42 to 62 miles per hour. Paris to Naples is also 800 miles. There are 11 trains per day each way, requiring 1 to 4 connections. Travel time is 13 to 19 hours, or 42 to 62 miles per hour. A train ticket in Europe may involve connections of as little as 5 minutes. In the U.S., a same-day connection is discouraged, or not allowed, at least on the same ticket. There are overnight sleeping car trains in Europe. The number is diminishing because of the increase in high-speed trains that make same-day business travel convenient, but there are still several overnight sleeping car train routes. Typical maximum speed for conventional passenger trains, not high-speed trains, in Europe is 90 to 110 miles per hour. Typical maximum speed for conventional passenger trains in the U.S. is 79 miles per hour, except for a relatively short segment in Arizona and New Mexico where the speed limit is 90 miles per hour, and the Northeast Corridor line between Washington, D.C. and Boston, where conventional passenger trains are allowed to operate at 100 miles per hour. Europe has high-speed trains all over the continent. As well, China has an extensive high-speed passenger train network. South Korea, Taiwan, Turkey, and even Uzbekistan have high-speed passenger trains. Kazakhstan received a demonstrator Talgo high-speed train set in 2000 after it completed a demonstration period in Washington state. Kazakhstan is building an 839-mile high-speed line. The planned 12-hour schedule requires an average speed of 70 miles per hour through mountainous terrain. A comparable trip in the U.S. is 764 miles between Chicago and Washington, D.C. The current scheduled running time is 17 3/4 hours, averaging 43 miles per hour. The top speed for the new Kazakhstan line will be 135 miles per hour. We have high-speed trains too. The accepted definition of high-speed rail elsewhere in the world is a maximum speed of more than 120 miles per hour. The U.S. rail network of 139,679 miles includes only 225 miles of high-speed rail, meaning speed limit of over 120 miles per hour as it's viewed in the rest of the world. Of the 225 miles, only 34 miles has a speed limit of 150 miles per hour. The rest has a speed limit of 125 to 130 miles per hour. But we're building more. Sort of. The U.S. government defines high-speed rail as a maximum speed of just 110 miles per hour or more. The U.S. has 11 designated high-speed rail corridors. There are just 238 miles of 110 miles per hour high-speed rail operating in the U.S. The California high-speed rail project, top speed of 220 miles per hour, is under construction. But of the approximate $98 billion that it needs, it has received about $7 billion in funding. There are 3 funded projects for 110 miles per hour requiring $23 billion, of which $3.4 billion has been allocated. There is 1 funded project for 120 miles per hour requiring $11 billion, of which $1 billion has been allocated. There is 1 funded project for 120 miles per hour requiring $11 billion, of which $1 billion has been allocated. There are 2 funded projects for 125 miles per hour requiring over $3 billion, of which $0.2 billion has been funded. There are other services that have planned improvement to 110 miles per hour speed, but those projects are not yet funded at all. But we also need much more than some high-speed trains, and we certainly don't need only a national pride true high-speed bullet train somewhere in order to say that we have one because they do and we don't. People in the U.S. don't understand how countries with bullet or true high-speed trains, as they call them, got to where they are. The conventional railroad network was improved until there was no more improvement that could be done. Then they began development of higher-speed trains. They did not start over from scratch with a new network. There are places in which the high-speed trains share the same lines with conventional passenger trains. The new separate networks for high-speed trains are constructed where there is no more practical improvement to the existing lines that will produce the desired result. Japan and Spain began their high-speed service with a new network because their conventional trains are not standard gauge, which was a disadvantage for the high-speed rail operation and expansion. This is successful high-speed rail. Bullet trains themselves are only part of the success. Convenience, punctuality, frequency, connections, and travel time are all essential elements. Generally, high-speed rail uses the same terminal stations and even some of the intermediate stations as conventional passenger trains in Europe. There are stations on the high-speed rail network in many airports such as Amsterdam, Frankfurt, and Paris. For example, there are 37 trains each way a day on the 342-mile trip between Frankfurt and Berlin. The schedule of ICE Train 74 from Zurich to Kiel tells an interesting story. It doesn't match the typical American impression of high-speed trains. In fact, it doesn't match several of the American requirements for successful high-speed train service. The top speed is 150 miles per hour, with long distances at 110 to 125 miles per hour. The trip is 653 miles with 13 intermediate stops. It shares a rail line with commuter trains, regional passenger trains, long-distance passenger trains, freight trains, and even streetcars. It connects with 220 other trains with connecting times of 4 minutes to 48 minutes. The train is often full. A reservation is a good idea, but it is not required. Typical park and ride at train stations in Europe accommodate mostly or only bicycles. Appropriate infrastructure, precision, and discipline are all essential elements for effective rail service of any type. In the U.S., a civil engineer generally knows nothing about railroad engineering until employed by a railroad or a railroad engineering company. A locomotive engineer and a train dispatcher assume responsibility after a few months. Conductors and switchmen assume responsibility after a few weeks. Managers learn about the workings of rail transportation after assuming responsibility. 2 universities in the U.S. have a railroad engineering program. Some others offer individual railroad engineering courses. That's the extent of training and education in rail transportation subjects. Elsewhere, countries that have effective rail transportation have substantial railroad science education and training programs. Germany alone has 11 universities and technical universities that have a railroad institute. All civil engineering students must take the basic railroad technology courses. A student may go on to obtain a degree specializing in the railroad field. Train dispatchers, locomotive engineers, and conductors must complete a 3-year technical school of railroad operation. There are 10 railroad colleges in Russia and many others throughout Europe, and 3 railroad universities in China. A railroad university is being developed in India with Chinese help. In Russia, even a locomotive engineer must have a degree in railroad science from one of the railroad universities. Knowing how it is done is essential to doing it right. Continuing the theme from another part of the program, rail innovation is green innovation. Rail innovation in the U.S. typically involves longer and heavier trains and track that can withstand longer and heavier trains with reduced maintenance cost. Rail innovation in Europe includes services that literally get trucks off the highway. Rolling Road is a service that does exactly that. One service is 54 trains a day on a 502-mile route. They're scheduled like passenger trains. The tractor and trailer are carried. The drivers have a special coach equipped to be a driver's lounge so that they are rested when it is time to take the truck off the train and hit the road. The load factor for this service is over 80%. The service takes 335,000 truck trips off the road annually. There is no equivalent in the U.S. Another service uses specially designed flat cars with a rotating deck to accommodate trailers. The train stops, the ramps are turned, tractors pull the trailer onto the platform and cut away. The platforms are rotated to the travel position and the train leaves. Intermediate stops can be made just as an intermediate stop of a passenger train. Typical intermodal service in the U.S., carrying trailers on flat cars, involves saving trailers for hours and then loading them using machines to lift the trailers onto the cars. The process is so time-consuming and expensive that it is not economical to carry a trailer for less than 500 miles. The number of services carrying trailers in the U.S. is diminishing because of the expense. Containers are loaded using the same machinery. More containers can be loaded onto a train because they can be stacked 2 containers high. Any traffic for which this arrangement is not convenient moves by highway. In Dresden, Germany, there are freight trams, or streetcars. Streetcars instead of trucks was determined to be a more efficient and traffic-friendly method to transport the goods than a fleet of trucks. A similar system, involving a distribution system of freight streetcars with final delivery by electric trucks, has been tried in Amsterdam. In Zurich, Switzerland, some municipal garbage collection is done by freight streetcar. There are high-speed freight trains in France, using equipment similar to the TGV high-speed passenger trains. A self-propelled intermodal train was developed in Germany for final delivery of containers, a method preferred to fleets of trucks operating between the rail terminal and the customer facilities. A self-propelled firefighting train is a Swiss variation of the concept. Rail buses, a single self-propelled rail car, provide low-cost passenger service on low-density branch lines. Decades ago, we had such vehicles and services in the U.S., but the political and economic aspect of rail transportation in the U.S. caused these services to be short-lived. The examples show what the U.S. could use railroads for but does not. They do not suggest that U.S. railroads do not already have an important function. Transportation policy and the economics of rail transportation as currently structured have caused U.S. railroads to become very good at one important aspect of transportation: large volumes of one commodity over long distances.